So let's find the work done by this force field, Fxy equals y squared, x squared over y, along the curve given by y equals e to the x, and x is bound between 0 and 1. So it's just another example of calculating the work in a non-conservative force field, all right? And we've given you a test to easily show that this guy is clearly not conservative. So we have to kind of do it the hard way by calculating the contour integral. So let's go ahead and find out our parameterization. All right, so again, x seems to be the natural parameter since I have this bounding value, x between 0 and 1. So if I let x equal t, then my y is just e to the t, and t is bound between 0 and 1. And since x is t, then dx by dt is 1, or dx equals dt, and dy dt is e to the t, so my dy is just e to the t dt. So here is my parameterization that I'm going to use to write everything in my contour integral all in terms of the one parameter t. So my limits of integration I'll express as t goes from 0 to 1. My force is y squared, or e to the t squared. When you raise a power to a power, you multiply the exponents, and then the y component of my force is x squared over y. So I'll get t squared over e to the t. And I want to dot that with my dr, which just has components 1 e to the t dt. So I get that from my dx dy. So now my work simply becomes the integral from 0 to 1. I have e2t times 1. If I keep my I dot I components, gives me 1. J dot j gives me 1. So I get t squared over et times et gives me just a plus t squared dt. So it actually became pretty simple. That's the great thing about having these engineered problems. They're usually pretty simple. So now everything is written in terms of t. I could go ahead and easily calculate this integral. I get the work equals. So remember, the integral of e to the alpha t is just 1 over alpha e to the alpha t. So I'll get 1 over 2 e to the 2t. And I'll evaluate that from 0 to 1. And then the integral of the t squared gives me a third t cubed, which I'll also evaluate from 0 to 1. So now my work becomes 1/2 e to the 2 times 1 minus e to the 0, which is 1, plus 1/3 t cubed is just basically 1 minus 0. So 1 cubed minus 0 cubed. And if I simplify a bit, I find that my work is 1/2 e squared minus 1/2 plus 1/3. And the best I can do really is join these two terms, which gives me work equals 1/2 e squared. So I need a common denominator. 3 times, say 2 is 6. 2 goes into 6 3 times. 3 times negative 1 is negative 3. 3 goes into 6 2 times. 2 times 1 is a plus 2. So my work ends up as 1/2 e squared minus 1/6 joules. Thank you.